So conic sections come from a double cone. And we are going to take a plane and slice through it at different angles. So when we slice through it at this angle, we get a circle. And we can get a lot of different circles. If we go just a little bit angled, we get an ellipse. If we angle it enough, we get a parabola. That's where we'll begin today. And then if we slice through both cones, it looks like two parabolas. They are called, it's called a hyperbola. And that is what conic sections are. Those are the four that we're going to focus on today. Or, well, I guess for the next couple weeks. All right, today we're going to focus on what a parabola is. You know what a parabola is, but we get to see parabolas that open up and down as well as left and right. Okay. So the definition of a conic section is a shape that is formed when a plane intersects a double-notched cone. Okay. Algebraically, you're going to get something like this, where we could have an x squared term, we could have an xy term, we could have a y squared term, we could have an x term, a y term, and a constant. Okay, depending on which of these variables are present will determine which type of conic section we have. We are getting back into graphing in rectangular coordinates, mind you. Okay, but we will be graphing each of these conic sections. Circles, you did back in geometry. Okay, we won't work a lot with circles because you know how to do them. When we work with ellipses, we'll talk about circles a little bit more. Okay, don't feel like you have to draw those pictures, please. You can look at your book for those, all right? What I want you to understand is that a plane is cutting through a double cone, and then algebraically it's going to look something like this. And like I said earlier, depending on which variables are present will determine the type of conic we have. We are not going to see this xy term until the very end of our chapter. Okay. Now, this next slide you don't need to write down, but are these all the possibilities of a plane cutting through a double-notched cone? It's not, is it? We could cut right through the vertex and get a point for it. We could cut right along the slant and get one line, or we can cut perpendicular through the cone and get two intersection lines. Okay, so technically we have these three options as well, but we're not going to worry about those. We're going to worry about these. All right, so today we'll work with parabolas. Next week we'll work with ellipses. The week after that, because next week is like 3 days, the week after that we will work with hyperbolas. So what I'm going to give you, with every conic section, you're going to get an algebraic property. For example, this is something that you learned in geometry. If you have a circle, then it's going to meet this algebraic property right here. X minus h squared plus y minus k squared equals r, where hk is your center. And all points on your circle are r away from the center. Okay, that probably would be a good thing to write down with the ACT next week. I bet there could be a circle question. So for each conic section, we're going to get a property. We're going to get an algebraic property, and then we're going to get this. A circle is the set of all points equidistant from a fixed point. So all of the points are the same distance away from the center. Okay, we know that that's the radius. Okay, what you don't know about parabolas is that there is a line and a point that we don't talk about. But this line and this point are important for things like satellites and light reflection and things like that. Okay. So what I'd like you to do first is write this down. And paraphrasing is fine, but a parabola is the set of all points that are equidistant from a fixed line and a fixed point not on the line. So new words, directrix and focus. The focus is going to be inside the parabola, and the directrix is going to be outside the parabola. And they have this really cool property that they are equidistant from, well, any point on the parabola is the same distance to the directrix, excuse me, as it is to the focus. Okay. Okay, everyone take a break from writing so you can watch what I point out. Here is our parabola. Okay. Our focus is inside the parabola and our directrix is outside. Notice that our directrix is perpendicular to the axis of symmetry. That will always happen. And what's true is that all points, so this point is the same distance from the focus as it is to the vertex. This point on the parabola is the same distance to the focus as it is to the directrix. This point, same distance to the focus as it is to the directrix. That's actually how a parabola gets its shape. You just never knew about the focus and directrix. Write down what you need. What? You don't need to write anything down. Or you're done writing, is that it? Yes. The focus will be on the axis of symmetry, yes. So the focus is going to be above or below the vertex if it's opening up or down. We are also going to talk about parabolas that open left or right. So in that case, they'd be to the right or to the left of the vertex. Okay, that's a good question. Okay, probably our after lunchtime will be spent graphing these, while our before lunchtime is going to be writing everything down. Okay, this is kind of the boring one, but it'll get more exciting. All right. So I know you know how to graph a parabola. What I want us to understand is how to create the parabola based off of the directrix and focus, and how do we identify the directrix and focus. Okay? So we're going to go through the standard form of a parabola. First, for a vertical parabola means it opens up or down, and then for a horizontal parabola means it opens left or right. So a vertical parabola is what we are used to. We are used to seeing x squared and not y squared. Now, you'll notice that the standard form looks a little bit different. This is so that we can easily pick out the vertex, the directrix, and the focus. We need it in this form. So I'm going to give you a moment to write those 4 things down. I know that I have these two formulas here for the directrix and the focus. I don't want you to remember K plus P and K minus P. That's not what I want you to remember. I want you to understand what a parabola looks like, what the directrix would look like if we graphed it, where the focus would be if we graphed it, and what I want you to remember is that the directrix and focus will be P away from the vertex, okay? That we're going to figure out that P value, and from the vertex, we're going to count that number away from our vertex so we can graph it, okay? That will be a lot easier to remember instead of these weird equations, okay? But we know we will have a horizontal line for our directrix because it has to sit perpendicular to the axis of symmetry. And we know our focus will be inside the parabola. Okay, so what we'll do is we will graph our vertex, we will count P inside, and we'll plot that point and then figure out what it is. And then we'll count P outside of our parabola and graph a line and then identify it. So really I want you to use the graph to identify things and then write them down. Okay. Okay, if this is the standard form for a parabola that opens vertically, what do you think is going to be different for a horizontal? Switch the locations of the x and y. So now y is squared, x is not. That's how we identify a horizontal parabola. Okay. I also want to point out before we identify everything else, that 4p is a coefficient, right? Notice how the coefficient is with the non-squared term. We're really not used to seeing that. That's kind of weird. That's different, okay? But writing it like this will help us identify that P, and then H and K are really easy to identify. Now, our vertex is still HK. Whatever is with the X is the X coordinate of our vertex. Whatever is with the Y is with the Y coordinate of our vertex. Don't get mixed around if they're not in the order in which we usually see them. Okay, yes, I know that Y is on the left side of our equation, but that K value is still the Y coordinate for our vertex. Okay, and then I'm going to say the same thing here. I don't care about these equations. I care about this. Our directrix and focus are P away. So now we have parabolas opening left and right. Okay? Eventually we'll even graph parabolas opening at an angle. Okay? But not for a while. We're pretty good at determining whether a parabola opens up or down. Let's talk about how we identify if a parabola is opening left or right. So first of all, we need to look at what the equation. What's different? Okay, we'll get to the coefficient. We have the y squared instead of the x. That's how we know it's horizontally. What is the coefficient going to tell us? What specifically about it?
Like if it's positive.
Okay, if it's positive, is it going to open right or left? It's going to open right. It's going to open in the positive direction. If our coefficient is negative, it's going to open in the negative direction. Okay, so if it's horizontal, it would open left. If it's vertical, it open down. Okay, it's just going to tell you the direction to graph your parabola. Okay, are you ready? We are going to start, and I don't know if we'll get all for this example before we go to lunch, but we have enough time to at least write it down and talk about it. Connor, which direction does this parabola open?
Vertical.
And why do you say vertical?
Positive.
Okay. What else do we need to look at?
Not sure.
Not sure. Now that we have two different kinds of parabolas, we have to pay attention to what in our equation? Which term is squared? Connor, which term is squared? Are we used to seeing that? No. Okay, so we have a horizontal parabola, and since we have a positive coefficient, which way is it opening? Right. Good. Now, our coefficient should be with the non-squared term, is it? Awesome. We don't have to do anything to that equation. Okay, so let's start identifying pieces, okay? First of all, we know it opens to the right, okay? So I'm going to make a note so I remember that. Our vertex, okay? I'm going to go ahead and talk about this one instead of asking you. Since there is nothing with the y squared and there is nothing added or subtracted to the x, our vertex is just the basic 0, 0. You're what? You're glad that we're not in polar anymore. There are ways to graph conics in polar, but we're not going to go there. We're not going to go there, I promise. Okay, so then we're going to take our coefficient, and our coefficient is 4p, right? So if our coefficient is 8, then that must equal 4p. What is our p value? 2. We have to identify that before we can identify the focus and the directrix. Okay? So when we come back from lunch, we're going to actually plot those. I want you to think about where we're going to plot the focus. That's the first thing we're going to do. I want you to visually think about where we're going to do that. And when we come back from lunch, you're going to draw it on your paper. Okay, so we just figured out that our p value was 2. So we are going to plot the focus. I'll plot the focus in red. Which direction do we need to move? Point. Which direction do we need to move for our focus to be inside the parabola? Point. Thank you, Gabe. Gabe's pointing. So from the vertex, we're going to go 1, 2. That's our focus. What coordinate is that? 2, 0. Now, that's our focus. Our directrix is going to P the other way. So here's our vertex. I'm going to label it V just so we know what it is. Okay? We're going to go P the other way. So now we're going to go to the other direction, but it's really not a coordinate, right? It needs to be a line perpendicular to the axis of symmetry, which means it will be vertical or horizontal. It will be vertical because the focus is lying on the axis of symmetry. Now that we have drawn our directrix, we can label it. What equation is that line? X equals -2. Okay. So once you have P identified, you can plot your directrix and your focus. Now it's a matter of just drawing the shape of the parabola. Now, I don't want you to just make a U and call it good, right? This coefficient affects how wide and how skinny our parabola is. Now, some of you are thinking, oh, well, that's a really big number. It's going to be really skinny. We're used to having the coefficient with the squared term. Right now, it's with the non-squared term. So we have to think inversely. Since that's a big number, it's going to be really, really wide. Okay? Now, how wide is it going to be? Let's use the fact that our any point on our parabola is the same distance from the directrix as it is to the focus. Now, on every parabola, there will be a coordinate, like this one, whose equidistant measures are perpendicular. Right? That'll happen on every parabola. Okay? I know where that's going to happen. It's always going to happen when we move 2p away. So what we're going to do, we're going to take our focus and we're going to move 2p away from it to draw a coordinate. So what is p? If we double p, we get. So we're going to take our focus and we're going to move 1, 2, 3, 4 away. How far away is that from the directrix? 4. Okay, then we're going to do it from the other side. Here's our focus. 1, 2, 3, 4. That's double p away. So it's 4 away from the focus and the directrix. Okay, that is how you're going to get the shape of your parabola. Okay, that way you don't have to think about how wide, how skinny. Just count from the focus 2p away and you'll get your shape. Okay, and as long as you do it correctly, it should be equidistant from the directrix. Okay, that was a nice example. The numbers were nice. We didn't have to rearrange the equation. All right, but oftentimes you are going to get an equation that is not in standard form. Now this is something we are used to seeing back in like chapter 2 of pre-calculus or last year in algebra 2. Okay. First of all, is this a vertical or horizontal parabola? Vertical, and we can tell that why. The x is squared. More specifically, it's going to open in which direction? Up. Our coefficient is positive. Okay? Now, in order for us to have it like this, we're going to have to complete the square, which is why I went over that right there. Okay? This is also what I want you to notice. The coefficient is going to be with the non-squared term. And we only want x minus h squared over here. Everything else is moved over. Okay? So the first thing I would do if it were me is I would subtract that 5/4 over. Because we need to complete the square on the right side, and that 5/4, we're not going to use it anyway. We don't want it. We want it on the other side with the linear term. Okay? Then, as we mentioned earlier, we can only complete the square if our leading coefficient is 1. So in this case, we are going to have to factor out a 1/4 from our x terms.
We multiply by 4.
Would you rather do that? You know, creative on me. All right, so 4y minus 5 equals x squared minus 2x because we multiplied everything by 4. It makes it a little nicer, right? Now, I know over there we added a number and subtracted it to the same side. What number completes our square? Okay. If we are going to add it to one side, we can also add it to the other side. So what we have is 4y minus 4 equals x minus 1, the quantity squared. And then, in order to be able to identify the y coordinate, what are we going to have to do on the left side? I think I heard the factor word. We would have to factor out that 4. You want x minus a number, and you need y minus a number. Any coefficient has to be factored out. Okay? If we had a coefficient with our x minus 1 squared, we'd have to divide it over. Okay? The coefficient needs to be with the linear term. All right, so we have our standard form equation. Right? So, our vertex. Ryan, where would our vertex be? What did you say? It wouldn't be at the origin. Go back and look here. We have x minus h here and y minus k here, right? So what number is being subtracted from x? What number is being subtracted from x? What number is being subtracted from y? Where's our vertex? Now this was nice because even if you got the x and y mixed up, wouldn't matter, right? But make sure the x coordinate comes from the x, the y coordinate from the y, right? Our coefficient is 4. Remember, our coefficient is always equal to 4p. So what is our p-value? Our p-value is 1. All right, so let's focus on the focus first. In which direction should we move 1 to plot the focus, Molly? Up. This is opening up, so we're going to move up P to plot our focus. So now we're going to label it as the coordinate 1, 2. If our parabola is opening up, our focus needs to be inside, so we move up P. Now our directrix is on the other side, so from our vertex, we'll move the other direction P. And what kind of line will we graph? Vertical or horizontal? You want a horizontal directrix. Now that I've drawn it, we will label our directrix as y equals 0. Okay, and as a reminder, you need shape. When I grade your parabolas, I will look for the double P points. Okay, where do we move double P from to get those points? Good, so from our focus, we will move double P. Since P is 1, we'll move 2 on each side. Notice how we have that equidistant property. That's a parabola. Any questions before we move to our last example? Okay, what I want to point out quickly before we move to our last example, Jackson had a really great idea of multiplying by that 4 so we could complete the square. What I was going to do was factor out the 1/4, right? And complete the square. His way made it a little bit easier for us. If you end up having to complete the square and there's a leading coefficient out in front, don't forget that that leading coefficient technically is being multiplied to that number, and that would affect the number that we put in to balance the equation. Since we added 4 inside, but that 4 is being multiplied to the 2, we were really adding 8. Okay? Now, Jackson thought ahead and said, let's just multiply by the 4 so you don't have to do that. That is great. But if you end up completing the square by factoring out first, I want to make sure you remember that. All right, last example. This is in standard form. You remember that standard form, not standard, excuse me, general form. General form of a conic is ax squared plus bxy plus cy squared plus dx plus ey plus x. Thank you, I can't think about my alphabet and talk at the same time. Okay, so you see that we have that general form. Now, we can recognize that this is a parabola because we have only one squared term. When we get to ellipses and hyperbolas, we're going to have x squared and y squared both in the same equation. But notice how we only have y squared. And because it's y squared, which direction is an opening? What do you say? To the right? To the right. We actually don't know if it's right or left yet. I know that you see that positive coefficient, but we haven't moved things around yet. We know it's opening horizontal. Okay? All right. So if we're going to put this in standard form, okay, what's true about the x's and y's in our equation for standard form? Are they together? They're on opposite sides of the equal sign. So I'm going to keep y squared and 4y together. And then I'm going to move 6x and 2 to the other side. I kind of ran out of room. Okay. Now, why did I move that 2 over? We don't want anything added or subtracted to our completing the square. We just want that nice binomial squared. So everything else gets thrown to the other side. Okay. This is nice. Nicole, what completes our square? No, since this is the y squared right here, b would be the 4. Good. So 4 completes our square, so we'll add it to both sides. Add it to both sides. Okay. So we have y plus 2, the quantity squared, equals negative 6x plus 6. They've been very nice to us, haven't they? Okay, we've had nice coefficients. Okay. So we have y plus 2 squared. In order to be able to identify both k, in this case h and p, we have to get the coefficient of x factored out. So we're going to factor out a negative 6, which leaves us with x minus 1. Now we can identify both the vertex and the p-value. Okay? Be very careful. Darby, where's our vertex?
Would it be negative 1, negative 2? No, 1, negative 2.
Good. 1, negative 2. Darby was not tricked, okay? Even though they're in the order of negative 2 and then 1, as you see it in the equation, we have to take the x first and then the y. So 1, negative 2. Will, you mentioned which direction this opens. Specifically, we know horizontally, but specifically which direction it's going to open. To the left. Okay, this is opening left. Okay, let's talk about P. Our coefficient is negative 6. Remember, our coefficient is always 4p. So P is negative 3/2. Now, because P is negative, it is opening in the negative direction, right? I'm really going to ignore the negative as I plot things. The negative's telling me we're going left, but I'm still going to count 1.5 for everything. So for our focus, since this is opening to the left, I'm going to count 1.5 to the left because that's my p-value. So our focus is negative 1/2, negative 2. And since I counted to the left for the focus, we'll count to the right 1.5 for our directrix. So x equals 5/2. And then for our shape, double P would be how many units? 3. So if P is 3/2, yes, negative, but the negative just tells us the direction. P is at 3/2, then from the focus, we're going to move out 3 units. That's our double P to get our shape. For some of you, the most challenging part of this assignment is going to be the algebra, getting it into standard form. For some of you, you may struggle with the graphing, okay? Whatever you do, or whatever you think you're going to struggle with, you have to do your assignment. Now, I don't see you for 4 days. That kind of seems like a long time. And I see you for 1 day, and then we get to skip a day and come back. In order to have a productive Tuesday, you need to do your homework this weekend. You'll notice that you have not very many problems, okay? These aren't all graphs either. Don't look at those and look, that's some graphs. Some of them are matching, some of them are just standard form, but then a handful of them are graphic. You need to do your homework, please. Okay? I will obviously come around and check it on Tuesday, but if you do your homework tomorrow, on your day off, at least look over it on Monday so you kind of remember what we're talking about. Okay? What we're going to do on Tuesday is we're going to get a graph and then talk about how to write the equation.